All right, lesson 10.7, circles in the coordinate plane, part 1. All right, if we have a circle, but now we're going to put its center on the origin in a coordinate plane. Okay, so the line from the origin to the side of the circle would be a radius. If we drop a straight line down, that creates a right triangle. This would be x distance, this would be the y distance, which would make that point xy. Okay, and if we use Pythagorean theorem, wouldn't x squared plus y squared equal r squared, right? Leg squared plus leg squared equals the hypotenuse squared. Okay, so that's an equation of a circle if the origin is on, if the origin is at 0, 0, center of the circle is at 0, 0. Okay, but what if it's not? Well, that's where we use the normal or the equation of a circle that will work no matter where it is on the coordinate plane. So the standard equation of a circle, we're going to take that original, but if it's moved anywhere on the coordinate plane, then we would just be able to take the x but subtract whatever the x coordinate is, okay, plus y minus the y coordinate, and we designate those HK because that's going to be the center of the circle, okay, equals r squared. All right, so this works, as I said, anywhere on the coordinate grid, which is the type of problems you're going to see more than it being on the centered on the origin of the circle, on the origin of the XY grid. All right, so in this equation, as I said, the center of the circle will be designated by the point HK. I want you to notice that the original formula has minus signs in it. So the H is whatever that number would be without the sign, okay? So if it said x minus 5, then H would be 5. If it said x plus 7, then H would be negative 7 because it would be like x minus negative 7, which would give us x plus 7. Okay, so we'll look at a couple of those. And then the other thing is just to remember that other side, the radius, is obviously the r. Okay, all right, let's try one with some numbers. So the first one we're going to look at, they're going to just give you the circle on the coordinate grid, and they're going to ask you, oh, that's actually pretty good. They're going to ask you to write the equation. Okay, so that's your y-axis and your x-axis, so they were nice and gave us so this is 3, negative 3, 3, negative 3. And what do we know? We know the radius is 3, right? So from the center out to the edge of the circle is 3 in all directions. And we know the center, in this case, they gave us an easy one with the center at 0, 0. So we plug in what we know into the standard equation. X minus the x value of the center squared plus y minus the y value of the center squared is going to equal the radius squared. Okay, so obviously x minus 0 is x, so we get x squared plus y squared equals 9. Okay, so you can see much easier, obviously, if the center of the circle is right on the origin. Okay, but what if it's not? Well, we're going to look at that one next. Okay, this time they're just going to tell you. So the circle center is this time at 0, -9. So it's not at the origin. And it has a diameter of 8.4. All right, couple things. Please be careful if the center this time is not at 0, 0, but also this formula uses radius. So if they give you the diameter, you have got to recognize that and be like, oh wait, the diameter is 8.4, the radius is going to be half of that. So the radius is 4.2. Okay, let's plug in what we know. So x minus the x value of the center squared plus y minus the y value, so y minus -9 squared equals the radius squared. Okay, so we get x squared, x minus 0 is x, plus y minus -9 is going to be y plus 9 squared, and that's going to stay just like that. And then we square the radius and we get 17.64. And that is your final answer. That is the equation of that circle in standard form. Okay. So this time we're going to write the standard form of the circle, and it's going to be based on what they gave us. So this is what it looks like. Now I didn't draw the coordinate grid, but they had it on a coordinate grid, so just kind of picture that. The center was at -1, 3. We have a point on the circle at -5, 6. Okay. All right, so first thing you need to do on this one is find the radius. They didn't tell us, and they didn't give us one where we could just count nice little boxes like that first one that I showed you. Okay. Side. All right, so 2 thoughts here. We need this line right here. We need this segment. So you could use the distance formula if you wanted and just plug those 2 points in. Okay, so you could use the distance formula, or what else could we use? Or we could use the Pythagorean theorem, because again, if this is on a coordinate grid, which obviously this is because it gave us points, couldn't we just create our right triangle? Okay, so it went from -5 down to -1, so that side had to be 4. It went from 6 to 3, so that side, whoops, other way around, sorry. That had to be 4. It went from 6 to 3 in the y vertically, so that had to be 3. Okay, so we could plug in what we know. 3 squared plus 4 squared equals c squared. 9 plus 16 and 25 equals c squared. Square root both sides. Your radius then is going to be 5. And if you memorized perfect triangles, you would have known that was a 3, 4, 5. Okay, so we know our radius is 5. We know that our center of our circle is -1, 3. So now we can go ahead and plug everything in. So we have x minus -1 squared plus y minus 3 squared equals 5 squared. X plus 1 squared plus y minus 3 squared equals 25. That would be the standard equation of that circle. Okay, now, what if they want you to graph the circle, but they give you this big long equation, x squared plus y squared minus 8x plus 4y minus 16 equals 0. These are the ones where you are going to complete the square first for both x and y. Okay, so we're gonna do completing the square like we talked about a little earlier today. Okay, so rewrite and group your x values. So x squared minus 8x, and then you're gonna leave a spot because we're gonna complete the square. Then we have a positive y squared plus 4y, and you're gonna leave a spot. Okay, so we're gonna complete the square with both of those, and then I'm gonna just add 16 to both sides because you don't want any other numbers over there when you complete the square. Okay, so we looked at this. Take your b, divide by 2, and square it. So we get -4 squared, which is 16. So we're gonna put plus 16. But whatever you do to one side, please make sure you do it to the other side, right? And then for our y term, we're gonna take the b, which is 4, divide by 2, and square it. So we get 2 squared, which is 4. So we add 4, but we add 4 to the other side as well. Okay. And over here we get 36. Over here, the whole reason for completing the square is to create a perfect square trinomial so that we can rewrite it as x minus 4 squared and y plus 2 squared. Okay, now a trick, we probably already talked about it, but I'm gonna say it again. Whatever this number is right here is what's going in the parentheses. This one was a positive 2, so went in this a positive 2. All right, now we're going to, actually, that's the standard equation of the circle, right? So from here, now we can pull out information. So the center is gonna be +4, -2, right? Because remember, those are gonna be, so x minus 4, y minus -2. So that comes out as -2. And my radius is gonna be square root of 36, or 6. Because remember, this side has to be your radius squared. Okay, so be careful of that. That's an easy mistake to make. And most of the time, they give you questions where your radius is a perfect square. So it kind of helps jog your memory to say, actually, I guess I wrote this in my notes. Let me just write that real quick. So the radius is gonna be the square root of 36, or 6. Okay. All right, so let's draw this and we'll do the best we can here. All right, so looks like I counted by 2s. 2, 4, 6, and -2, 2, 4, 6, 8, Okay, let's graph what we know. So center is 4, -2, and I'm counting by 2, so this is 4, -2 is gonna be right there. My radius is 6, so I'm gonna count over 6. 2, 4, 6, 2, 4, 6, 2, 4, 6, and 2, 4, 6. Okay, no, of course it's not gonna fit my circle. Okay, so your circle is gonna look better than mine probably. Somewhere along this line. Okay, and that would be how you would graph a circle, but you have to be able to complete the square. They're gonna be looking for that, so make sure you understand that process right there.